Today we're going to be talking about section 5.2, direct variation. We will start today off by looking at some vocabulary. Remember that you can pause anytime if you would like to do the homework as we go through the notes. And of course, you can always revisit things if you need to see the explanation again. A direct variation is a relationship that can be represented by a function in the form y equals kx. K cannot be 0, something to remember. The constant of variation is usually referred to with the variable k, and the equation y equals kx can also be written as y divided by x equals k. So here we have a definition. Direct, of course, means straightforward. I want to kind of talk about the math definition. So if the ratio of two variables is constant, then the variables form a direct variation. For example, one variable directly affects another by multiplying it by a constant value. Here's some examples where both variables increase. The more expensive the car, the more sales tax that you are going to pay. So one directly affects the other. Here we have one variable increases while the other decreases. So as a candle burns longer, its height gets smaller. Again, one directly affects the other. So that is where direct variation comes in. Let's look at an example here. So in this first example, does this equation represent a direct variation? If so, find the constant of variation, which is your k. If the equation represents a direct variation, then it has to be written in this form, y equals kx. So go ahead and solve the equation for y to determine whether it can be written in that form. So if we look here, we subtracted the 6x, then divided everything by 3, yet we still have this 3 here. So it is not in the form y equals kx, so it cannot represent a direct variation. Basically, anytime you have something here in the equation that's adding or subtracting to the x, you're not going to have direct variation. So let's look at this example here. Does this represent a direct variation? If so, find the constant. So we want to find k. So we need to go ahead and solve this equation to get y by itself. So we would start by subtracting the 4x and moving it over to the other side. So we'll have 5y equals negative 4x. Then, of course, we want to get y by itself, so we're going to divide both sides by 5. So y is going to equal negative 4/5 x. And since there's no other value here, it does follow the pattern for direct variation, and our constant of variation, our k, would be negative 4/5. That represents k, or it's the coefficient of x. So I guess I can also say yes, it does represent direct variation. I'm going to turn my notes page here. So the next example is writing a direct variation equation. So we're just going to kind of fill in the missing pieces here. It basically just kind of walks you through step by step how to do this problem. So suppose y varies directly with x, and we know y is 10 when x is negative 2. What direct variation equation will relate x and y given these parameters? and what is the value of y when x is negative 15. So as I said, this is kind of taking you through this step by step. So think of this as step 1, step 2, so on and so on. So first you want to start with the function form for direct variation. So we can either have k here, or in some cases we can have m because we know that that represents slope. So what we're going to do there is we're going to substitute 10 for y and negative 2 for x. So we're going to do a little bit of substitution. So instead of y here, we're going to have 10, and instead of x here, we're going to have negative 2. And we can use, I usually use m because I know that's my slope, but k can also be put there in that place. Now, step 3, we're going to divide each side by negative 2 so we can solve for k. So I would get negative 5 equals k, my constant. Remember, that's also m. They're kind of interchangeable there, and sometimes I can interchange those without even thinking about it. So then the next step is to then write your equation by substituting in negative 5 for k or m. Remember, those can be interchangeable. So y is going to equal negative 5 times x. And then determine, now that we have the equation, determine the value of y when x is negative 15. So at this point, we just plug in that negative 15 for x, and we get an answer of 75. So again, breaks down for you step by step how to do this problem, just by filling in some of those missing pieces, remembering that m and k are kind of interchangeable. But whenever you see a problem like this on your assignment, just follow these steps just like it's written out here. So if you want to pause here and do some of those problems, great. Otherwise, we're just going to continue on. Now, problem number 3 is dealing with graphing and direct variation. So here we're talking about weight on the moon varies directly with weight on the earth. So a person who weighs 100 pounds on earth weighs 16.6 pounds on the moon. So what we want to know is what is an equation that relates the weight on earth and the weight on the moon. And then we want to see a graph of that equation. So again, this kind of walks you through step by step how to do this problem. So first, we need to find k. We need to find that constant of variation. And we, in this case, are going to round k to the nearest hundredth if necessary. A lot of times they'll say tenth or hundredth, so just make sure you read the directions there. So in this first problem, we have the weight on the moon is 16.6 pounds, and that is going to vary directly with our weight on Earth, which is 100 pounds. So I basically plugged in 16.6 for y and 100 for x. Now we're going to solve for our constant. So I would divide by 100. If we're going to round our answer, so I'm going to just round it to 0.17. Round it to the nearest hundredth. So k is 0.17. So that means y is going to be, or our equation is going to be y equals 0.17x. So we're going to use that equation to make a table of values. Think about just your XY chart, and then we would take those ordered pairs and graph them on our graph here. So for example, if you weigh nothing, you would multiply that by 0.17, and of course, you would still be 0. So what about 25 here? If we take 25 and plug it in, we would have 4.25. And we just continue along, plugging in 50. We end up, sorry, I meant to put 0.175 there. I'm thinking ahead. Let's try that again. So that should be 0.17, pretty much all the way down. And multiply our constant by each of those values. So we should get here 8.5, then 17, then 21.25, and so on and so on. And then, of course, we would graph our x value compared to our answer here, which would be our y value. So just kind of approximating where they go. We would start with 0, 0. Then our next value is 25 and 4.25. So you just kind of estimate where that point would go. It's not going to be perfect. Then 50 and 8.5. And again, we just kind of estimate where that would be. And then we go 100 and 17. So 100 up to approximately where 17 would be. And then 125 right here, and 21.25 approximately. So we can kind of see that relationship here, graph those values to show that direct variation is happening. If you want to connect the dots together, you're more than welcome to do that. I'm going to go turn my notes page and go to the next part here. So here we have a concept summary, kind of what we've been talking about. So here it says the graph of a direct variation equation is a line with the following properties. The line passes through 0, 0, and the slope of the line is your k value. So if you substitute 0, 0 in, for example, to this equation, we can see what happens. So we're going to plug in 0 into our equation here. So kind of an interesting thing here, 0 does not equal 3. So because this graph does not pass through 0, 0, because it doesn't work when you plug it in, the equation cannot be a direct variation. So it has to go through 0, 0. And you can test that point in any equation to see if it works or not. So let's look here at this last example that we have today, writing a direct variation from a table. So for the data in the table at the right, does y vary directly with x? If it does, write an equation for that direct variation. So here again, we're kind of setting this up as a ratio. So we're going to take our y value in our ordered pair over our x value. And we're going to do that with each of those points. So negative 0.75 over 1. And then here we would have negative 3 over 4. So we're going to check those ratios. This, when we simplify it, equals negative 0.75. This, of course, would equal negative 0.75. And here again would equal negative 0.75. So for the data in the table, does y vary directly with x? Our answer would be yes. They all have the same ratios, or they all equal each other as a decimal. So the equation for the direct variation would be y equals negative 0.75x, because negative 0.75 represents k, You could also think of it as